Hey, what's up, you guys? It's Miss Brothers. I just wanted to take a few minutes and walk you through this review, Unit 7 review. A couple of these I'm not really going to go through, like, for instance, number one, what is a subscript? You can find that in your Quizlet vocabulary. I'll go ahead and walk you through a few of these, you guys, but I'm not going to spend my whole time on this. Really, I want to get to the conversion problems on this. So the number 2 says, use this formula to answer the following questions. That's the formula we're using right there. I'm asking you to make a list of the elements and the number of atoms. So as far as listing the elements, you guys, we have Na, that equals sodium. We have H equals hydrogen. We have C, that equals carbon. And sorry for my crappy handwriting. And we have O, which equals oxygen. And as far as how much, you have to remember, you guys, that when it comes to the number of atoms, we're just using the subscripts or no subscripts to tell us what we have. And remember, you guys, we also have a coefficient, which is telling us the number of molecules of this we have. So there's 2 molecules of this. So if we were to, like, draw a little box around this whole thing, there's 2 molecules of this compound right here. Now, as far as what's in it, what you have to remember is that you have to apply the coefficient to absolutely everything in this formula. The subscripts, not so much. So let's start with our sodium. Sodium, you guys, right now, if we were just to hide the subscript, if we didn't have the subscript, we would have 1 sodium. I'm sorry, the coefficient. But because we have a coefficient, we can say that we have 2 atoms of sodium. Right now, in this set of parentheses, we have a single hydrogen, but we've got a subscript outside of the parentheses. So this subscript right here applies to everything that's in these parentheses. So that means we have 2 hydrogens. But remember, I've got a coefficient of 2 out here, which means that we have a total now of 2 hydrogens times 2 equals 4 hydrogens. Inside right now, I've got a single carbon. But this subscript means that I have 2 carbons, and then I have to take that 2 carbons, multiply it by this 2, this coefficient out front, which means I have 4 hydrogens. And finally, my oxygens. This little subscript right here only applies to the oxygen, so I have 3 oxygen. But I have to multiply it by the subscript, which means I have 6 oxygen. But remember, I still have to multiply by this coefficient, which means I now have 12 oxygens. Now, as far as what is the total number of atoms in this formula, all I have to do is add these together. So 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 12 is 22 atoms. As far as calculating the molar mass, this is actually something that we practiced. You're actually going to want to go ahead and use a periodic table in order to do this. So let's go ahead and do this one, because this one is pretty quick, but this will be a good example, and you can apply it to the rest of it. The potassium is really easy, because all you have to do is look at the atomic mass of potassium, and the atomic mass of potassium is 39.10 AMUs, or if we're dealing with molar mass, there's 39.10 grams for every 1 mole of potassium. Okay, so let's go ahead and do this one right here, the glucose, because the glucose, and this is just for a reminder, you guys, that what we do is we use our periodic table. So I've got carbon, I've got 6 carbons, I have to multiply that by 12.01, because the atomic mass of carbon is 12.01 grams per mole. So if I do that, then I end up with a total of 72.06 grams of carbon. Hydrogen, I've got 12 of those hydrogens. That's what that subscript means. The atomic mass of hydrogen is 1.01 grams per mole. So if I multiply that, I'm going to end up with 12.12 grams. And then oxygen times 6. Oxygen has an atomic mass of 16, so if I take 6 times 16, I end up with 96.00 grams. And if I add all of those together, I end up with a total molar mass. So if I have 1 molecule of glucose, it means I have 180.18 grams per mole, so 180.18 grams per mole. That's the molar mass. So if I have 1 mole of sugar, it means it would weigh 180.188 grams. It's a lot of sugar. Okay, I'm not going to do the rest of these because the rest of these basically work the same way. You have to use the periodic table. use the number of atoms you have, and then add them all together, and you end up with your molar mass. Right. Now, as far as these next ones, we're going to go ahead and work on these. Now, the hard part for everybody, you guys, is this idea of when to use a one-step and when to do a two-step. And what I need you to understand, this is one of the things that I will show you tomorrow, and I'll just go ahead and write this up here, so that you need to understand direct conversions versus indirect conversions. If it's a direct conversion, we're basically going from grams to moles, or liters to moles, or particles to moles. So one-step conversion means we're going moles to grams, we're going moles to liters, or we're going moles to any particle. And remember, you guys, particles are going to be things like atoms, or molecules, or units. Like for entire formulas, those are particles, okay? Now, in terms of, those are things that we can do one-step. Two-step, because if I'm using a two-step, it means I'm going from something like grams to liters, or liters to grams, or I'm doing particles to liters, or particles to grams. Something where I can't do a direct, which means I have to do moles first, and then I have to do my last step. And this is a really good example of that, number 4, because what I'm doing is I have grams, and I'm getting to particles. That's not a direct conversion. That's sort of an indirect conversion, which means I have to use two-step. Okay? So I'm going from grams to particles. So grams to particles. That means I have to do, this is going to be a two-step. And this is what I'm talking about. So I've got 95.0 grams of silver. Ag is that's the atomic symbol for silver. Now again, you guys, I can't convert right from grams to particles, which means I have to go to moles first. So 1 mole of silver. And if we look at the periodic table, and we want to know what the mass of silver is, we just look at the periodic table, and it will tell us that the mass of silver is 107.87 grams. And what that means is that if I have 1 mole of silver atoms, and I put it on a scale, it's going to weigh 107.87 grams. Okay? Now, like I've said previously, I like to do my canceling right now. So I'm going to go ahead and cancel out my grams of silver. Now remember, you guys, I'm trying to finish with particles. Excuse me. Trying to finish with particles. So I'm not quite there yet. The unit that I have left is moles. I have to get rid of moles. I have to convert it to particles. So I'm going to put 1 mole of silver down here. And if I'm dealing with particles, it means I have to use Avogadro's number, 6.02 times 10 to the 23rd. In this case, particles. I'm going to abbreviate that P-A-R-T-A of silver Ag. Oops. Not very tidy. Sorry. So now that I have these, now I have my problem set up, I'm going to cancel out my 1 mole of silver here and my 1 mole of silver here. And if I look, the only unit I have left is particles, which is awesome because that is the unit I want to end up with. So now let's go ahead and set up our math. Up top, I've got 95.0 times 6.02 times 10 to the 23rd particles of Ag over 107.87. If I do my math on that, I've got 95.0 times 6.02. I'm going to tap my EE button because I am using the 30XA. There's my EE button. Type in 23. Hit my equal sign. Now that I have that number, I can divide by 107.87. And that leaves me with my final answer of 5.30. Because I'm just going to go ahead and round this to the nearest hundredth, times 10 to the 23rd, that's my exponent right there, and that's going to be particles of Ag, and that is going to be the answer that I'm going to circle. Hooray! So again, you guys, because we started with grams, and we had to convert to particles, that means we had to use our little helper here. That's a two-step process. Now, you guys, I'm going from moles to silver. Moles to silver, you guys, I can do a direct conversion on that one. So this automatically tells me that I'm doing a one-step right here because I know that I can do molar mass because it says so right on my little cheater sheet. And we know that molar mass is already given to us as long as we can use the periodic table. So I've got 25.6 grams of silver, and I'm just going to abbreviate that AG again because it's fast. I've got 1 mole. I know I have to finish here. 1 mole of silver. And based on the one I already did, I know that my molar mass of silver is 107.87 grams because I just did that in the last problem of AG. So I can go ahead and do my canceling. I'm going to cancel out grams of silver. So that leaves me, my only unit left is moles of silver. So I'm going to go ahead and set up my math. 25.6 moles of AG over 107.87. I'm going to go ahead and do my math there. So 25.6 divided by 107.87 leaves me with a final answer of 0.2. And I'm going to go ahead and round that up. You can see I'm sitting here at 0.237. I'm going to go ahead and round that up to 0.24 moles of silver. And that is going to be my final answer right there. Okay, let's go to number 6. I'm trying to find grams. I'm given liters. Now, if we look up here, you guys, if I'm doing, in this case, liters to grams, that is an indirect conversion, and again, I'm going to have to use my two-step process right there. So let's go ahead and set up what I have. The unit I'm given is liters, so 855.4 liters of CO2. Set up yield T-chart here. Again, my only conversion is going to be to moles at this point, and I've got 1 mole of CO2. And remember, you guys, if you recall, if I have a mole of any gas, no matter what the gas is, it's going to be 22.4 liters of that gas. In this case, the gas is CO2. Okay, I'm going to go ahead and cancel out my units right now. So liters of CO2 is canceled, leaving me moles of CO2. But again, you guys, I have to finish with grams. So I'm going to go ahead and put 1 mole of CO2 down here. That way I can cancel out this set. And remember, you guys, if I'm doing molar mass, it means I'm going to have grams of CO2 up here. And I have to calculate this mass. So I know that carbon, I've got 1 carbon. I know that it has a molar mass of 12.01 grams. I've got 2 oxygen, so I've got oxygen times 2, which equals 32.00 grams. And if I add those together, I get 34.01. Boy, that's really sloppy. Sorry, you guys, it's so sloppy, but this is what happens when you get into a hurry. Did I do that right? No, I added that wrong. That's supposed to be 44. Come on, girl. 44.01 grams. That's what I'm going to put right here, 44.01 grams. So far, so good, I think. Yeah, that looks pretty good. Now I can go ahead and set up my math. I'm just going to go ahead and set that up down here. I have 855.4. I can cancel out my moles here and here. I'm going to multiply that times 44.01 grams of CO2. And I'm going to divide by 22.4. And again, you guys, I'm going to do my multiplication first. So I've got 855.4 times 44.01 equals, I'm just going to go ahead and leave that in the calculator for now because I don't feel like writing all of that down. And I'm going to divide that by, divided by this, 22.4 equals, and I end up with 1,680.63 grams of CO2. And that's going to be my final answer for this problem. And again, you guys, that the whole idea of doing that two-step process, it's because I don't have that direct conversion from grams to liters or liters to grams, I have to convert to a mole first. Then I can do that conversion to liters or grams, depending on what I'm starting with. Hey, let's do page 2, shall we? Oops, sorry, that was messy. Sorry. All right, here's page 2. Let's do number 8. I'm sorry, number 7. If you have 83.5 liters of HCl, which is hydrochloric acid, what mass of hydrochloric acid would you have? So you're like, well, what unit do I have here? Well, what unit you're trying to get to is if I have a unit of mass, it means it's going to be grams. Okay? So again, you guys, we are doing a conversion from liters to grams, which means this is going to be a two-step process right here. Again, we don't have that direct conversion, which means we have to take this volume of HCl, we have to convert it to moles first, so let's do that. So I've got 83.5 liters of HCl, again, hydrochloric acid. And I want to make sure that I convert it to moles of hydrochloric acid. And if you remember, you guys, if I'm dealing with a volume of gas, I'm going to use 22.4 liters of HCl. Now I can go ahead and cancel out my liters of HCl, and I'm left with moles. I'm going to go ahead and put a mole of HCl down here so that I can cancel these, and now I have to calculate my mass of this hydrogen chloride, otherwise known as HCl, otherwise known as hydrochloric acid. And again, you guys, I've got hydrogen times 1 equals 1.01 grams. I've got a Cl times 1 equals, I believe that's 35.45 grams if I look on the periodic table. And if I add that together, I end up with 36.46 grams. So that's going to be the molar mass of HCl, and that's what's going to go right up here, 36.46 grams of HCl. Now that I have this, I can cancel out my mole of HCl here and my 1 mole, blasted that lead, woohoo, HCl right there. And now I can set up my math. 83.5 times 36.46 grams over 22.4. I'll go ahead and throw that in my calculator here. So I've got 83.5 times 36.46 equals, and it really is important to hit that equal sign first before you decide to do your division, divided by 22.4, which leaves us 135.91 grams. Oops, I forgot my HCl there. Shame on me. HCl. And that's going to be the answer that I circle. All right, number 8. How many moles are there in 547.4 grams of ammonia? How many moles? Now, because we're going moles to mass, that's easy. We can do that in one step. So I've got 547.4 grams of NH3, otherwise known as ammonia. I've got to finish in moles, so I'm going to put mole up top here, NH3. And down here I have to have grams of NH3 because that's the unit that I'm going to be able to cancel out. Now I am going to have to take a second because I do have to calculate the molar mass of NH3. So I'm going to go ahead and draw a little line here to separate the last problem. I've got nitrogen, I've got 1 nitrogen, and that's going to be a molar mass of 14.01 grams. I've got 3 hydrogens, so that's going to be hydrogen times 3 equals 3.03 grams. And if I do my math, I end up with 17.04 grams. That is what I'm going to put right here. And I'm already ready to do my math, so I'm going to cross out my grams of ammonia here and here. And now I can set this up. I'm going to have 547.4 times, oh, I guess I don't really need to times because I just have a 1 right there. So 547.4 moles of NH3. And I'm going to set that over 17.04. I'm going to set that up in my calculator. I've got 547.4 divided by 17.04, and that equals 32.12 moles of ammonia NH3, and that's going to do it for number 8. All right, number 9. I have grams of mercury. I want to know how many moles I'm going to end up. This is another one step. Anytime I'm going from grams to moles or moles to grams, I can do that in one step. All right, so let's sit 258.89 grams right here. I'm going to put that over 1 mole. And what is that? That's mercury, otherwise known as Hg. I'm going to use the chemical symbol for mercury. I've got 1 mole of Hg right here. I've got to have grams down here so I can cancel it, grams of Hg specifically. And if I look at the periodic table of elements, what I learn is that the molar mass of mercury is 200.59. Now I didn't have to add up anything, you guys. I'm dealing with a single element here, mercury, so all I have to do is just look at the periodic table, and I'm going to be able to find that atomic mass right there. Okay? So again, 200.59 grams of mercury. I can cancel out my units of grams of mercury right here. And so I'm left with 258.89 moles of Hg over 200.59. We grind that through the yield calculator, so 258.89 divided by 200.59 equals 1.29 moles of mercury, otherwise known as Hg. I'm going to check my work to what I did earlier. That's exactly what I got before. I got it again. I'm on fire. All right, let's do number 10. All right, I have the number of grams. I have to find the number of liters, and if you remember, you guys, if I'm going from grams to liters or liters to grams, that's going to be a two-step process. So I'm going to go ahead and set up my grams, 35.9 grams of NH3. And look, you guys remember NH3? We just did that one. That's going to come in super handy because we just calculated that mass a few minutes ago. Look, there it is. So that's going to save us a little bit of time. We're going to go ahead and set this over 1. Now remember, you guys, I do not have a direct conversion from grams to liters. So that means I have to calculate moles first. So I'm going to go ahead and set this to 1 mole of NH3. Down here, I'm going to have grams of NH3 so I can cancel it. And like I said before, I already calculated the molar mass of ammonia at 17.04 grams. So that's what I'm going to go ahead and use down here. 17.04 grams. So I can go ahead and cancel my masses here. Now I'm not done yet because remember, you guys, my final unit has to be liters. Right now the only unit I have left is moles, so I'm not done yet. I've got to get rid of moles. I've got to convert it to liters. 1 mole of ammonia NH3. And if you remember, you guys, whenever I'm doing moles and liters, if I'm doing that conversion, I'm going to use that constant of 22.4 liters. That means whatever gas I have, if I have a liter of it, or if I have 1 mole of it, it means it's going to be 22.4 liters, or it's going to occupy the space of 22.4 liters. And that's going to be NH3. So now I can go ahead and cancel my 1 mole of NH3 here and 1 mole of NH3 here. I can set up my math, 35.9 times 22.4 liters of NH3 over 17.04. And if I do my math on that, I'm going to bust out my calculator again, 35.9 times 22.4 equals 804.16, but we're not quite done yet because I've got to divide by 17.04. And that's going to go ahead and give me my amazing total of 47.19. And that's going to be liters of ammonia. So NH3 And that's going to take care of number 10. We're doing good. All right, number 11. I want to know how many moles there are in 1.704 times 10 to the 24th molecules of this compound, SFX. Now, you guys remember, molecules is a particle, so we are going to be using our constant of Avogadro's number in this one. And remember, you guys, I can go directly from moles to particles, okay? So this is going to be a single-step process. So I have 1.704 times 10 to the 24th molecules of SF6. Okay? So I have to finish with moles, so I know that 1 mole of anything, regardless of the substance, in this case the substance is SF6. If I have a mole of anything, it's going to be 6.02 times 10 to the 23rd particles, in this case molecules, of SF6. Okay, so like I said, it's a direct conversion. So the first thing I can do is cancel my molecules of SF6. I'm going to do that. And so now I'm going to go ahead and set up my math. I've got 1.704 times 10 to the 24th mole, because I have that unit left over, of SF6 over 6.02 times 10 to the 23rd. So let's go ahead and get out my handy-dandy 30XA solar calculator. I'm going to type in 1.704. I'm going to hit my EE button right here, which is the number right above my, or this button right above my 7. Type in my 24 exponent. I'm going to divide that by 6.02 EE to the 23rd. And I'm left with 2.83 moles of SF6. And that is indeed my final answer. All right, number 12. How many liters are there in 2.4 moles of NH3? Now, liter to moles, you guys, that's a direct conversion. That means we're going to be doing this in one step. So I've got 2.4 moles of NH3. It's our good buddy ammonia again. Okay, so I have to make sure that I have moles down here so I can cancel. So 1 mole of NH3. And remember, you guys, if I'm trying to find liters, remember 1 mole of any gas means it's going to occupy the space of 22.4 liters of NH3 in this case. And I can go ahead and do my canceling. So I can go ahead and cancel out moles of NH3 here and moles of NH3 here. And now if I can set up my math, 2.4 times 22.4 liters of NH3. And if I just go ahead and stick that in my calculator, that's going to be 2.4 times 22.4 equals 53.76 liters of NH3. Okay. We're getting closer and closer. All right, let's do this next one. Number 13. So I'm trying to find grams. How many grams are there in 4.32 liters? Now, if you recall, you guys, grams to liters or liters to grams, we don't have a direct conversion there, which means I'm going to have to do that extra step of converting to moles first. So I'm going to start with my 4.32 liters of sodium iodide. Set that over 1. Now, I have to be able to cancel out liters, and like I said before, I don't have a direct conversion from grams to liters or liters to grams, which means I have to set up moles first. So I'm going to set up 1 mole of NaI right here. And remember, you guys, if I have liters of something, if I have 1 mole of any gas, the liter equivalent is going to be 22.4 liters of NaI. I'm going to go ahead and cancel my units now, while there's just a couple of them. And remember, my final unit has to be grams, so that's what has to go up here, specifically grams of NaI. And if you remember, I'm going to set mole right here, 1 mole of NaI down here. That way I can cancel it when the time comes. And I have to get the molar mass of NaI, which means I'm going to have to use the periodic table. And if I use the periodic table, what I know is that sodium, and I've got 1 sodium, equals 23.00 grams. And that's just slightly rounded up, all right? And if I'm dealing with iodine, I've got 1 of those. And if I look at the periodic table, I know that my mass of iodine is 126.9, is it 90? Yes, it is 90 grams. And if I add those together, I end up with a molar mass of 149.90 grams, and that's the quantity I'm going to fill in right here, 149.90 grams. Now I'm going to go ahead and set up my math. I'm just going to go ahead and set it up. Oh, I'll just make myself a little line. I'm going to set it up right here. 4.32 times 149.90 grams of NaI over 22.4, and I forgot to cancel out this. Bad. And once I do that, I can do my math. I can do 4.32 times 149.90 equals this number, 647.568, divided by 22.4, which leaves us with a total of 28.91 grams of NaI, sodium iodide, and that is my final answer for number 14. Okay, last one, number 14. I want to know how many moles are in a volume, specifically 85 liters of CO2, which is nice because that's going to make this, I can go directly from moles to liters, which is going to make this a one-step problem. I've got 85.0 liters of CO2. I have to finish with moles, which means I'm going to put 1 mole of CO2 right here. And underneath it, I'm going to put liters of CO2. And how many liters? Well, if it's a mole of any gas, it's going to be 22.4 liters. I can go ahead and do my canceling. Canceling here, and I can set up my math. 85.0 moles of CO2, because that's the only unit I have left, over 22.4. If I plug that into the calculator, I've got 85.0 divided by 22.4 equals 3.79 moles of CO2. And that is, again, my final answer. All right, and again, you guys, for tomorrow's test, I will help you out with a periodic table and just some reminders about when to use one-step versus when to use two-step. That information should come in handy. And if you have any questions, let me know. I have posted the key to the review already, and I will be posting the key to this video in just a little while.